This paper was presented at the JCT Traffic Signal Symposium 2024, thanks to our media partner Highways News, and sponsored by AGD Systems, Four-Way Consulting, Traffic Group Signals, Smart Micro UK, TRL Software, PTV Group, Census Networks, and Starling Technologies.
Good morning, everybody. Over the last year at Four-Way, we've had a really large increase in the number of active travel schemes that we've been working on, which have all been incorporating segregated cycle facilities. Which button is it? That one. So across our team, which is a sort of a mixed experience team, we've been having to get our heads around in detail of what latest design practices, what guidance tells us that we should be doing, what perhaps it tells us that we shouldn't be doing, or even what it doesn't tell us at all and that it should be telling us. The schemes we've been working on have been very mixed, a lot of them from the smaller sites up to larger sort of Cyclops style junctions, including those along a sort of large corridor with multiple junctions along them. Interestingly, all of our schemes have generally had one thing in common, in that although they're cycle schemes, generally I think when the signals are turned on, we're not expecting that many cycles. This is kind of a build it and they will come. It's encouraging modal shift. But we've had to be making sure that our designs have been relevant to that, so those lower flows, but also anticipating how it could be in the future. And the first thing that we've had to really look at as a team, and I thought I'd highlight, is nothing to do with the signals. It's all to do with the users and actually who's going to be using these junctions and what are they going to be riding? Because they could be on what you or I might know as a bike, and they could be a very competent and confident cyclist. Someone, I don't know, cycles to work every day, cycles for fitness, and they kind of know what they're doing. But they could also be a novice cyclist, could be a child, or maybe somebody who's seen the new infrastructure and said, yeah, this is a good opportunity for me to leave the car at home and get on the bike to go to work. But they're perhaps not as experienced out on the roads and not as confident, and our designs need to take account of that. But they also might not be riding what we commonly think of as a bike. It could be towing a trailer. It could be a recumbent style or a cargo bike, which are typically much larger, much wider, with the rider in a completely different position to a conventional bike. It could be a tuk-tuk style, last mile delivery vehicle, all of which are bikes and all can use the cycleways, but all have different properties. They're much generally larger and less manoeuvrable. And I think as well, whilst it's not a bike, and they're generally not even legal, in the lifespan of the signals we're designing now, e-scooters quite potentially will become legal. So anything that we're doing needs to take account of that. So actually reflecting how these users could be using it and how we might also detect them. So those are some of the challenges of the users, looking at how we've actually been incorporating that into our designs. So on the screen, it's a simple amalgamation of a few sites we've worked on to actually get the example. And first point is, how do we signalise or signify to cycles where they need to stop and whether it's on red or green? Because Chapter 6 tells us that we can use a single signal head for a cycle phase, but doesn't give any more information over when you perhaps should use a single or whether you should use a primary and secondary, or even whether it should be a low-level cycle head or a full height. And we've been adopting, generally for the schemes we're working on, a do minimum. And we've been bringing in just a single low-level cycle head on a pole to the near side of the cycle lane as it comes onto the junctional crossing. Figuring that it's generally in the cyclist's line of sight, reduced street clutter, reduced embedded carbon, reduced costs, and also that toucan phases, which we've had for years, generally incorporate just a single signal head. So if we can actually reflect that in our designs, why do we need to do more normally? There'll always be some cases. Hand in hand with the signal head, we have to have a stop line. That's the one piece of the guidance and regs which is very clear. It has to be there. doesn't really tell us where that stop line has to go though. We've typically been following a sort of style of motor vehicles and putting our stop line in advance of the signal head. We've been settling on normally about half a metre before the signal head, and that signal head's normally on a pole half a metre-ish off the curb, so we're setting the stop line back about a metre or so from the curb edge. I know there are some people who bring the stop line in line with the pole, and I've seen that, particularly in Holland. If you look on Google Maps, a lot of sites have that. But also seen TfL guidance, which suggests having it a good metre or more before the signal head. Because one of the things we struggle with on the schemes we've been working on is space, or generally the lack of space. Because even with how we've got things now, if our stop line is a metre back from the curb, and you've got a large bike, a cargo bike or something that could be 3 metres long, we're talking the back of that bike's 4 metres behind the curb edge, and where you've got pedestrian routes and maybe conflicting cycle routes as they're turning left or right, squeezing everything in is really challenging. So I really don't know whether we're putting the stop line in the right place, and we'd really like feedback from others, because should it be before the signal head, in line with the signal head, at the curb edge even? Or do we even really need a stop line for a cycle phase? Because does it really make that much difference to where a cyclist is actually going to stop? I'm not certain. And if that's how we're trying to signalise red and green to a cycle, we now also need to detect them. And multiple ways that we could be doing it, and we're generally trying to keep things simple. So sort of the primary detection we're using is a straightforward push button. Nothing complicated there at all. Positioning it though needs a little bit of thought, and we're typically putting that 1.5 metres back before our stop line, which is generally going to feel quite a long way. But if you're riding those unusual bikes and your hands are nowhere near the front of that bike, we bring that push button too close, we're actually going to be forcing that cyclist to cross a stop line at red to reach the detection point, which isn't good. But again, we have problems of space and where that pole can go for that push button and how it impacts the other users of the junction. So hand in hand with the push button, we're looking to use above ground detection as well. And again, we're normally keeping it quite simple and bringing in an above ground detector, curbside detector at the stop line, using it in 2 ways, both pairing it as per we would do for a pedestrian phase, so pairing it with the push button, but also being able to automatically demand from that curbside detector if a cyclist has just paused at the stop line for a few seconds, they automatically get a demand. Using the weight lamp on the push button to signify to the cyclist that they have received a demand, I think is a good thing. I know some people think we don't necessarily need the push button, and I'm inclined to agree if we can get the automatic demands working well. But also then looking at other types of detectors, and I know there are plenty of different detector types out there, but if we were to go away from the push button immediately now, I must admit, I'm still struggling to have 100% confidence that we could put a detector at or near the stop line, which is going to demand every type of bike that could possibly be there, and e-scooters and everything else, and not falsely demand other pedestrians and things that may stray into that cycle route. I'd love it to be the case that those detectors are there, and then we could potentially do away with that push button, but I'm not certain. Hopefully it will be soon. So we're generally keeping it simple. You'll see I haven't mentioned anything about advanced detection, where sort of cyclists coming in and detecting them further back. We do it sometimes, but we've so often found we cannot reliably detect at a point, say 20 or 30 metres away, and know that that cyclist is going to that crossing, because they could be turning left, turning right, going somewhere else other than that crossing. So we're generally keeping it simple. The other point to note with this, if we do away with the push button, is do we need to do something else to signify to a cyclist that a demand has been lodged? We don't do it for motor vehicles, but if we would have very low cyclist flows, do we need to consider of how can we signify to them that actually a demand has been lodged, you don't need to do anything, just wait a moment and it will go green. Or, because if we don't have that, are we actually going to end up with cyclists who think, well, I've been waiting here 30 seconds, it's not working, I've not been detected, and they're going to be more likely to jump the red? I'm not certain. Should we have a red, amber, green weight lamp sort of thing on a 4-aspect cycle, low-level cycle head? That's a kind of the physical nature. We've also been looking at a few things in the signal operation to try to help cyclists and to really help give a high level of service to the cyclists that the schemes are sort of primarily intended to enhance facilities for. So on the screen, one of the sites we've been working on, it's a work in progress screen grab when I took it, so forgive mistakes on there. But as is common on many of these sorts of sites, we put a cycle crossing in. It's a long straight across crossing, which leads us to have all-round pedestrian and cyclist stages to service that demand. So we stop all motor vehicles and then allow the peds and the cyclists to cross. Now they're great from segregation and safety, but on larger junctions such as these, we're typically running a 2-ish minute cycle time maybe. And if your average wait time for a conventional all-round pedestrian cycle stage is probably going to be a minute, could be virtually immediately, could be up to 2. But if you've got an average wait time of a minute and you have a few of these junctions along a route, that waiting time for cyclists can really add up. And I cycle frequently, and I'm not going to say I start jumping red lights or anything else, but by the time you're waiting a long time, or what feels like a long time at a junction, a bike can easily circumnavigate the signals, and we want to try to make sure that that doesn't happen, because we want to really encourage the use of the facilities. So we've developed a little technique, fairly simple, not going to be useful always, but sometimes, where in our stage sequence, we're putting in multiple options of an all-round pedestrian and cycle stage. So in this example, we've put 3 replicas of the same stage in. We never intend to run all 3 stages in any one controller sequence, but we pick out one based on where the cycle or pedestrian demand comes in. So if we were in stage 6, motor vehicle stage 6, and the pedestrian and cyclist demand comes in, we run stage 7 next. And then we lock out the other 2 options until the controller's gone through a full sequence and returned back to where it started. The idea being is where we have a low number of cycles, of sporadic demands, they'll always be able to get their demand serviced in the next available stage. If we've got a busy site with lots of pedestrians and cyclists, it's not going to provide any benefit. The controller's going to lock down to running the same stage always. But where we've got those lower flows and off-peak periods, we're hoping it will really reduce the waiting time for cyclists without adversely impacting the motor vehicle capacity at the site. And looking at a different aspect of timings and operation, minimum greens. If you have a motor vehicle, typically get a 7-second minimum green out on site. Chapter 6 says it could be as low as 5 seconds though. And cyclists can be on the road too, mixing it with motor vehicles, so you can get a 5 to 7 second minimum green. Toucan phases, 4 to 6 seconds of typical minimum green. But put in a red, amber, green cycle phase, and chapter 6 says 7 seconds minimum, which to me, again, with low cycle flows, why do we need a long minimum if it's going to be delaying other vehicles, if it's not providing a benefit to maybe the one cyclist that's there? So we're routinely running a lower minimum green on cycle phases where conditions permit. Hopefully it's still going to be perfectly reactive for the cyclist and provide the level of service they need to get established, but it's going to minimise delays to other users. It's not always going to be appropriate though. And one of the specific examples is on another scheme I've been working on, where as I call it, the primary cycle route crosses 2 arms or more of the same junction. So on this side, the northern and eastern arms. And what we're trying to do is, again, keeping it nice and simple, where we pick up the demand from the outer sort of points on that entire crossing route. If we get a demand from those areas, we're using that then to create an extended minimum green in the controller so that the cyclist can cross both arms of the junction in one movement. By doing that, we minimise the waiting time of cyclists because they wait once instead of twice. But also, hopefully, we're going to minimise the frequency that an all-round pedestrian stage needs to be demanded. So if we can do that, we can then minimise the delays to motor vehicles at the same time. But it does beg the question, why don't we do this for pedestrians, where the main pedestrian route crosses 2 arms of a junction as well? Anyway, that concludes where I've got to. This is generally how we've been doing things at Four-Way recently. That's almost just to prove that some of us are cyclists out around signals. So any feedback or questions from anybody?
Thank you very much, Tom. And I just want to pick up on a throwaway comment almost from you. But what a strange world we're in now, where we're having to provide for large numbers of vehicles which we know are illegal, and another group of vehicles whose legality is dubious. What a strange situation to be in. But I'm sure we have some questions. Yes, there's one there.
Thank you very much. Is that working? There we go. Thank you very much. I think, Chris Kennett, Chris Kennett Consulting. Like yourself, we've got a lot of recent experience with very, very similar schemes. And you were talking about the push button and whether you could remove it. We did on one of the first ones where we were told cyclists don't like push buttons. They want to be treated as vehicles. We're having to go back and put the push buttons in because all the cyclists actually, in practice, arrive and then seeing that there's no push button, they move on to the puffin crossing next to it and use that and stand there and press that.
That's really useful to know.
Yeah, and it's not a true Cyclops, it's more of a sparrow crossing through the middle of a junction. But I will note, whilst the cyclists who commute love it, the residents think that it's very, very difficult for them to use, hostile for pedestrians.
Yeah, I think certainly although it's not overly clear on the presentation, but so much you can fit in, managing the conflicts behind the cycle crossings between the cycle route and the pedestrian route is challenging, and generally, thankfully, outside the scope of the works we've been doing as a general rule.
Another question? One more? I really need to look
Guess who?
Mark Pledel. Tom, thank you. Really interesting. I wrote down several questions and you answered most of them as you went along, so really good. At the end, when you were talking about basically running extended green for the cyclists to get them across two crossings, I then looked at the lining and marking and realised that those cycle routes are bidirectional. And that made me start to think about tidality or tidal flows in cycle movements and whether those are a problem or whether I'm just making up a problem because it struck me as a potential issue.
No, I think it could be a problem, in all honesty, on these schemes, because the cyclist flows are very low initially.
Yep.
We don't know. I think we're going to be looking at sort of the internal section there of utilising detection in those points to properly extend the green rather than having a sort of a fixed minimum. But
Cycle VA.
so well, on those sites are going to be cycle mover.
Yeah.
And it's just kind of allowing that to happen, but there comes a point of how much complexity do we build in at the certainly at the start of the schemes.
Thank you.
Right, thank you very much.
Okay.